Function Virtualization, also known as NFV. It is a modern networking approach where traditional hardware devices like routers, firewalls, and load balancers are replaced with software versions that run on virtual machines. It was first introduced by Etsy around 2012 to help operators deploy, scale, and manage network services more efficiently. Instead of relying on physical appliances, NFV move network functions into software, which gives more flexibility and reduces cost. In traditional networks, every network function requires its own physical device, a router, a firewall, and so on. With NFV, these functions runs on a virtual network functions or VNFs on standard servers. This approach offers clear advantages, lower costs, flexible scaling since we can create or remove functions easily, and much faster service deployment. NFV works by separating network functions from the hardware layer. The VNF is a software version of the network service. Under the VNFs, we have the virtualization layer, which is usually like hypervisors like VMware or KMV. At the bottom is a physical hardware. We also have the NFV infrastructure or NFVI, which includes compute, storage, and networking resources. Finally, we have management and orchestration, which is responsible for controlling the lifecycle of all VNFs, including deploying, monitoring, and scaling them. These are the three components of an NFV system. First, VNFs. These are the virtualized network functions such as virtual routers or virtual firewalls. Second, the NFV infrastructure, which is combination of physical servers, storage, networking, or virtualization layer. And third, MANO framework, which is defined by Etsy. MANO handles orchestration, automation, and management of all VNFs and resources. A good example of NFV is a virtual router. Instead of buying a physical hardware router from a vendor like Cisco, an ISP can deploy a virtual router on virtual machine or even a container. It runs on general purpose servers using hypervisors like VMware or KMV. This makes updates, scaling backs, and migrations much easier as compared to physical hardware. Now we'll talk about the benefits of NFV. NFV provides several important benefits. It reduces capital and operational costs because we no longer need specialized hardware appliances. It allows easy deployment and scaling of services, giving operators more flexibility. Automation becomes easier through orchestration tools. NFV encourages rapid innovation because new services can be tested and deployed quickly. And finally, it improves energy efficiency because resources are utilized more effectively. However, NFV also comes with challenges. Virtualization introduces performance overhead and may add latency. It can be difficult since VNFs from different vendors must work together smoothly. Security becomes more complex because virtualized environments create new attack surfaces, and managing large number of VNFs requires advanced orchestration systems, which also include complex to configure. Now we'll talk about NFV and their related technologies. NFV is closely related to other technologies. It works with SDN or software defined networking, where SDN controls the network flow while NFV runs smooth network functions. NFV also fits naturally into cloud computing, where virtual machines or containers host the VNFs. And edge computing, VNFs can be deployed close to end users to reduce latency and improve performance. I will talk about real world use cases. NFV is widely used in modern networks. In 5G networks, many components such as the core network and base stations are virtualized using NFV. ISPs use virtual firewalls, virtual load balancers, and virtual NAT systems. Enterprises use NFV on demand VPNs, network slicing, and scalability security solutions. Major telecom operators like vendors like AT&T, Verizon actively use NFV in their projects. Now we'll talk about the future of NFV. The future of NFV is moving towards cloud native network functions, also called as CNFs. These run on containers instead of virtual machines. With AI driven orchestration, networks will become more automated, self handling, and more efficient, with self healing property intrigued in them. NFV will continue to play a major role in 5G, Internet of Things networks, edge computing, and next generation cloud infrastructure. Now we will talk about the summary. In summary, NFV transforms traditional hardware based networks into software based, flexible, and scalable systems. It reduces costs, improve deployment speed, enables faster innovation. NFV has become a core technology for modern telecom network and cloud environments. Overall, NFV is a major step towards more agile and efficient networking. Thank you.